right, so we're going back to the notes that look like this. It says complex numbers on it. Before I go on, is there anyone who needs the guided notes? All right. So I'm gonna get mine out. All right, so let's finish up our talk about complex numbers. First of all, complex numbers are those things that involve the letter I, right? And we said that I stood for the square root of -1. So whenever you see I, that's all it means, right? We said we had some properties of I, such, I think the biggest one was when we square I, we get -1, right? So we can square it to get something that is a real number. We talked about adding and subtracting them, combining them in different ways like multiplication. We even talked about dividing, which required us to multiply by the complex conjugate. And we also talked about weird powers of I. So we were able to calculate I to the 200, for example. And I think, let's see, where did we leave off here? I think we left off at example number 3, which I want to talk about really quick before we go on, because I got a question about the homework. There's something on the homework that looks like this, and you're asked to like multiply by the complex conjugate, things like that. I think on WebAssign, on a test or quiz, I would be fine by getting this answer. There's no I's on the bottom. There's an I on top. Don't remember which one. Yeah, I think it was the last problem. This one, it looks like this, definitely. I think if you type in this answer, it will say that you're wrong. Yeah. Okay, good. So, or not good, but good that I remember it. I think what it wants you to do is first split up the number. So you're going to split this up into 26 over 34 plus 32 over 34i. Okay, and I think even if you type that in, it'll get it wrong because these fractions aren't simplified, right? Yeah, so 26 over 34, I think they're both divisible by 2, right? So that would be 13 over 17. And then 32 over 34 are both divisible by 2, right? So that would be 16 over 17, good. I think WebAssign will take that answer. So if you're getting marked wrong there, try splitting up the fraction and also simplifying the fractions. Hopefully you'll be okay. All right. Another thing about the homework is there's a very big factoring question on there. Oh, Winter. So what do we do with the problem? Okay, just send me an email and I'll just add points to your score. Yeah, if you got this one wrong a lot, just send me an email and I'll manually change it. Okay. I think there's another question on WebAssign that involves a lot of factoring. The numbers are really big, but you can go about it the same way. If you need help, just email me. Okay. All right, so done talking about that, done talking about WebAssign. Let's talk about 2 more types of questions that can arise with complex numbers that don't really look like complex number questions, but they are. So for example, we have some more funky stuff going on. We have, oh, Steven? Yeah, it doesn't look like an imaginary number, but it kind of does. So we have 5 minus the square root of -9 minus 1 plus the square root of -4. Now we know that I stands for the square root of -1, right? And we don't see that there. Any ideas on maybe what we can do?
Separate the square root of 9 and square root of -4.
Yeah, right. When we have a square root, it's the same thing as an exponent. So when we have 2 things multiplied on the inside, we can break it up. And let me just show you what that looks like. We have 5 minus, and I can take that square root and separate it into the -1 times the +9. Okay. So you can always break apart a square root when you have multiplication on the inside. The same thing goes with the other one, but I have -1 times +4. Okay. Well, we know the square root of 1 is I, right? So maybe instead of writing the square root of -1, I'll write I. Typically I is always written after the number. I don't care if you write it before the number, but let's just go ahead and write it after. Okay. Now I can do the multiplication now, but anything we can do to make it easier?
You can square root of 9.
Yeah, right. If you go in your calculator, type in the square root of 9, you're going to get 3, right? 5 minus 3i, and then -1 plus 2i. Okay. How about this? To wake up our brains, I'm going to give you a couple minutes to work on this. Try to simplify it, and we'll come back. Ainsley, to write up this one. Ainsley, do you kind of want to take us through your steps? Awesome job. I really like how Ainsley wrote the -1 instead of the I squared. You don't have to do that, but I promise you it will save you from a lot of mistakes if you write the -1 and show that, show this step. Oop, that step. Any questions on example 1? All right. Let's move to example 2, which I think is going to answer Riley's question, but I'm going to tell you don't worry about it for now. So let's say we want to solve 5x squared plus 2x plus 1. Okay. And maybe I tried calculating and it didn't work. And I really don't want to complete the square. And I can't square root right now. So maybe I want to use the quadratic formula, right? Quadratic formula is pretty easy. And it's already in the form for the quadratic formula, right? We have A here, B here, and C here. Okay. Is there someone who can remind me of what the quadratic formula is? Amara? Mm-hmm. There's a 4. Okay. There's a square root. Mm-hmm. Not plus, but minus. A plus or minus?
Yeah.
Uh-huh.
And then 2a.
Okay, there's one more thing. There's a minus sign in front of the B, but good job there. Okay, so remember you have to memorize this formula, but good job, Amar. For the test on Friday. Let's just plug in, right? So we have a -2 plus or minus the square root of 2 squared minus 4 times 5 times 1 all over 2 times 5. Okay. So I think we can do some cleaning up here. We've got a -2 plus or minus the square root of 4 minus 20 over 10. All right, we have 4 minus 20, which is -16 over 10, right? Okay, we have a square root of a negative, which normally we used to say there was no real solutions here. Any ideas on what we can do? Grace? Perfect. And let me show you a step to get there. But that is a nice observation here. We can do the same thing as we did in the last problem when we had a square root of a negative, right? We can take apart the negative and the 16 and put them in their own square roots, right? Okay. Well, the -1 turns into an I, so we have 2 plus or minus the square root of 16i over 10. And as Grace figured out, the square root of 16 is 4. So instead of writing that bulky square root, let's write 4. -2 plus or minus 4i over 10. Okay. This is how far I would go. Of course, you could write out the positive version and the negative version, but I would take this on a test. This is basically as much as you have to worry with plus or minus and square roots. So don't worry about anything else. Any questions on this example? Yeah. All right, and this is the end of the guided notes for this section, and this is actually the end of the guided notes for the exam on Friday. I do want to touch on one more thing before the exam or before the end of class, because we do have a little bit of extra time. But anything we cover after right now is not going to be on the test on Friday. It'll be on the second test. Okay, so new set of guided notes. All right, I promise I'm not going to try to fill your head with stuff that's not going to be on the exam for too much. So I promise we won't do too much today, but let's get started on this. I think we have some time to do that. All right, so new section, other types of equations. We're going to talk about different types of things that look a little bit weird that can show up in our equations. So the first thing that can show up in an equation is this weird symbol that we call the absolute value symbol. And we say that the absolute value of a number is the positive version of that number. Okay. Now, the way that we kind of use, the way we kind of symbolize this term, the absolute value, is we'll take a number and we'll stick these two straight bars around it. Okay, so we'll take -5 and stick two straight bars around it. If the absolute value is the positive version of a number, what's the absolute value of -5? +5, good. So literally just make that number positive. Okay, we can even take the absolute value of a positive number. What would the absolute value of 3 be? 3, good. All right. So basically take the number on the inside, make it positive. Okay. Well, we went from an absolute value of a number to the result. Let's see if we can go backwards. Okay. So let's say we have x, which is a number, and we know that if we take the absolute value of x, we know the answer is 2. What can x be?
Plus or minus.
Plus or minus 2. It could be 2 because the absolute value of 2 would be 2. It also could be -2 because the absolute value of a negative number is the positive version, right? So we have two answers here. We have x equals 2 and we have x equals -2. Okay, so we have two answers here. Okay, and essentially whenever we solve an absolute value problem, we basically get the absolute value on one side of the equation, and we basically have two different versions of our problem. Yeah.
Instead of writing out x equals positive 2 and x equals -2, can you just do x equals plus or minus 2?
Yeah. So, gosh, Allison did a really good question. You can also write your answer like this: x equals plus or minus 2. So let me just show you how to go about solving an absolute value question in an example. I think that kind of clears it up a little bit better. We have this example, 2 times the absolute value of x minus 5 plus 3 equals 11. Okay, let me show you how I would go about doing this. The first thing I would do is I want to get the absolute value by itself, okay, because that's kind of like the hardest part of the question. Let's try to isolate it and see what we can do. Okay, so I'm going to subtract 3 on both sides to get 2 times x minus 5 equals 7. No, is it 8? Good. All right. And then, well, 2 is being multiplied by the entire absolute value, kind of like parentheses. So I'm going to divide by 2. Yeah. So you can kind of imagine the absolute value symbols as parentheses, right? Okay, x minus 5 equals 4. Good. Now we're at the point where we have the absolute value of something equaling 4. Just like we did in example 2, if the absolute value of something equals 4, then we have two solutions, right? We have the positive version, x minus 5 equals 4. And we also have the negative version, right? Because the absolute value can either be a positive or a negative. Okay. So I always write the negative on the right. You can also change the signs on the left if it makes you feel more comfortable visualizing this. But I like sticking the negative on the actual number. Okay, so basically what I did is I rewrote the equation twice. On one side, I took away the absolute value symbols and just left the equation alone. On the right-hand side, I took away the absolute value symbols and I changed the 4 into a negative. Okay. So we can solve both of these, right? I can add 5 on both sides and get x equals 9. And I can add 5 on both sides here. That gives me 1. Okay, so two answers, x equals 9 and x equals 1. Any questions on what I've done here? Awesome. All right, so try example 4. You can try splitting up the equation, but make sure you get that absolute value symbol by itself first. So we have -4 times the absolute value of 2a plus 5 equals 12. My suggestion to you is whenever you see an absolute value symbol, make sure you try to get it on one side of the equation by itself. So the -4 is kind of messing it up, right? Let's divide by -4, which I think I saw everyone do. And we're getting the absolute value of 2a plus 5 equals -3. So we got the absolute value on one side. We know we have to have a positive version and a negative version, but the answer on the right, or the number on the right, -3, is negative. It's not positive, right? What did we do? We split it up, right? So we had 2a plus 5 equals something, and 2a plus 5 equals something else, right? Okay. Well, one of them we left the equation alone. So one of them's got to be -3. What's the negative version of -3? +3, right? If you want to think of it in your mind as doing this, -3, that's okay. If you want to skip this step and just write the positive version, that's also okay. All right. So let's solve our equations. We can subtract 5 on both sides. 2a equals -8, right? Dividing by 2 on both sides, we get a equals -4. Okay, so that's one of our answers. On the right-hand side, we have 2a plus 5 equals 3. Subtracting by 5, we get 2a equals -2. And dividing by 2, we get a equals -1. So those would be our two answers to the question. Any questions on example number 4? All right. You know what? I promised you I wouldn't do too much of new stuff that isn't on the test today. So how about this? I'll let you out a little bit early. Sound good? All right. Make sure you study for the test. We will review tomorrow. So we will be prepared for our test on Friday.